4.3 trig extended circular functions. So there are going to be a couple little note things, but didn't really warrant a video, so.
Okay.
All right, so we're going to have basically an angle here. And so this is going to be the initial side. Then up here is the terminal side. And then this angle here is, I'm just going to call it A. And that's more just for reference for when the book starts talking about those words, you know what they mean. So the big thing in this section is coterminal angles. So to find coterminal angles, for degrees, we have theta plus or minus 360 degrees. So it's basically every time around where it hits, those are all coterminal. And then for radians, it's theta plus or minus 2 pi. Now, obviously, because most radians are written as fractions, it's going to be some form of 2 pi, but it's going to, it's going to be a fraction that reduces to 2 pi. So then I'm going to draw a coordinate plane here, make it big enough to write in. So I'm going to have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And then in there, I'm just going to write the signs of sine, cosine, and tangent. So in quadrant 1, everything is positive. Quadrant 2, sine is positive. Cosine and tangent are negative. In quadrant 3, sine and cosine are negative. Tangent is positive. And then in quadrant 4, sine and tangent are negative. Cosine is positive. Which you should know enough about sine, cosine, and tangent to be able to figure that out anyways, but sometimes it's nice just to see it. All right, so the first one says to identify the one angle that is not coterminal with all the others. So basically, you're given a list of angles. So number 2, 5 pi over 3, negative 5 pi over 3, 11 pi over 3, negative 7 pi over 3, and 365 pi over 3. Now, it tells us that 1 is not coterminal with the rest, so we're just going to check until we find the one that's not. So I'm going to save 365 pi over 3 for the end and seriously hope that that's not the one, because that's going to be miserable. So if I want to find which one's coterminal, I'm adding or subtracting increments of 2 pi, but these are all pi over 3, so what would the fraction that I'm using be that's equivalent to 2 pi? Like, get a common denominator with 2 pi.
12 over 3?
Nope. 6 pi over 3, so I'm using increments of plus or minus 2 pi, which in this case is going to be plus or minus 6 pi over 3. So I always just start with the first one, work my way across. So 5 pi over 3 plus 6 pi over 3 is 11 pi over 3. So I can put a check on that one. That one's good. And I was able to use that one, so obviously that one's good. So now I'm going to do the subtracting because otherwise I'm going to be adding a lot to get to 365 pi over 3. So I'm going to start subtracting from 5 pi over 3 now since that's the original one that I used. So minus 6 pi over 3 would give me minus pi over 3, which isn't one listed, so I don't need to do anything, but I'm going to subtract again. So minus 6 pi over 3 gives me negative 7 pi over 3. So that one works. That means I skipped negative 5 pi over 3. So this is the one that does not work. Which then implies that this one would work because it tells me that there's only one that doesn't. Now, you could also multiply this by, you know, some really big number to eliminate having to subtract off, like, or add that many times. But if all the rest of them work, you know that's the one that doesn't, and vice versa. So
being coterminal basically means like they have to be able to subtract or add to get to each other, basically.
Yes. So like if you had your unit circle, well, this one isn't filled out, but that's okay. So if you had your unit circle and you started at 30 degrees, right? So you add 360, that's coming all the way around again. Well, 360 plus 30 is 390. So it's saying that 30 degrees and 390 degrees will give you the same values, basically. So we usually just want the most basic one, but they're just asking you to find like other angles that are the same as it, basically. And obviously adding and subtracting in degrees is way easier than in radians, so. Find a positive and negative coterminal angle. Is that even asking? Scratch that, we're not doing that. Okay. Point P is on the terminal side of angle theta. Evaluate the 6 trig functions for theta. If the function is undefined, write undefined. So, number 8, we're given the point -4, -6. So we, in general, graph this. It doesn't need to be to scale by any means. So where would this point fall? Like what quadrant?
3.
Quadrant 3. So I'm just going to get it as close as possible. Now remember, when we have something like this, we always are caring about, undo that. We always care about the angle that's touching the x-axis, not the y. Okay, so anytime you draw a point on and you're looking for the angle in the 6 trig functions, you care about it with respect to the x-axis. Okay, don't draw it touching the y, draw it touching the x. So we know that the x value is -4, y value is -6. How would I go about finding the other side? Pythagorean theorem. So C is equal to the square root of, and since it's getting squared, I'm just not going to write the negatives, 4 squared plus 6 squared. So that ends up being the square root of 36 and 16, was that 52? And I'm just going to leave it, even if theoretically something could come out, I'm just going to leave it just to make it look nicer. I don't know.
For the sake.
Pretty much, yeah. Now again, if you did take stuff out I wouldn't take off for it. I just usually don't. Sine of theta, cosine theta, tangent theta. So we're solving for all 6 trig functions here.
So this is the same as the last section, just putting it on a graph, basically.
Yep. So once you plot the point, it's exactly the same as the other stuff. So it's just a matter of plotting it in the right spot, basically.
Yeah.
That tends to be the only issue with these. Like if once they're plotted correctly, everyone's fine. It's just if you don't plot them correctly, your answers tend to be wrong. So what is sine of theta?
Well, it's negative 6 over square root of 52, but can't have that on the bottom. So say negative 6 square root of 52 over 52.
And that can be reduced
Okay.
to 6 and 52.
To like something.
And take out a 2. You 26 on the bottom. So negative 3 square root of 52 over 26. And again, you're more than welcome to go right to the negative 6 square root of 52 over 52. I'm just writing it for if you go back and look that you see where we did. Cosine.
Negative 4 over, well, yeah, negative 4 over square root of 52. Then it'd be negative 4 square root of 52 over 52, and reduce it. So, negative,
4 is going to go into 52.
so, negative square root of 52 over
13.
13.
I only knew that off the top of my head because 48 and
Oh,
4 is
yeah.
12, so.
So, makes sense.
And then tangent would be what?
Negative 6 over negative 4, which makes it positive. But, can be reduced to 3.
So then cosecant would be what?
Square root of 52 over negative 6.
Secant.
Square root of 52 over 4, negative 4.
And cotangent.
2 over 3.
And the whole thing about you would get all the sides right. I guess I should specify if you plot the point at least in the right spot. But if you connect it with the y-axis, your angle's going to be wrong. So that's what ends up making it wrong. I guess I should have specified that. All right, number 10. The point negative 3, 0. So, where is that going to fall?
On the
On the
X-axis.
X,
Yeah. On the x-axis. So, it's going to be back here. Obviously, can't make a triangle with that.
There was just the, so would it be?
So, what would that mean? It's what?
Undefined.
Undefined. I'm just going to draw a quick in each quadrant because there's not really a lot of problems like this in this section. There was a lot more like in Algebra 2, but I'm just going to draw where the point would be plotted, so like in each quadrant what the triangle would look like, just so that you have it to reference. So obviously we already did quadrant 3, right? That's one we just did, so I'll do the other ones. So if it's in quadrant 1, it's going to be like that. Quadrant 2, there. Quadrant 3 was up in the other problem. And then quadrant 4 would be like this. So that way you just have it to reference when you go back, because I trust that y'all can all plot a point.
I don't know if I know how to do that.
I'll send you the Algebra 1 video where I taught it the other day.
Yeah, I miss algebra 1. I miss those days.
For reals.
It's really easy.
I tell you though, some of it's so hard to like teach because it just makes sense to me. So I'm
Yeah.
like they're like, not that they necessarily ask why, but like trying to give them the why it's like that. I'm like, it just is.
It just,
That's why I don't like geometry, just because I don't
No,
know
It's
I
like
how
think
to
even-
explain it.
Even this morning, they were like, okay, so that triangle problem that's on the board over there. They were like, so do I need to use a calculator for that problem? And I was like, well, I don't think you know what the sine of 50 degrees is just off the top of your head, so yeah. And they were like, so they've always had a calculator? And I was like, well, no, obviously not. I was like, what? Anyways. So I was like, yeah, I know, I'm like, okay.
They'll be good at
Um,
proofs, I guess. Next year.
Oh my gosh. I was looking at my application and I have to take a placement exam for math because I did worse on that. And I'm just gonna wait until school's over because it goes up to pre-calculus trade.
That's what I always tell people, like, that's why, like, I told people, like, don't set out of math, like, everybody's like, I'm not going to take math senior year. You're going to regret that when you go take your entrance
I need
exam.
to go back to like pre-algebra if I skip math. Like,
Yeah.
if
Well, I sat out of math for 2 years and greatly regretted it. So, because I took everything in high school. So when I got to college, I had nothing, like, literally went to Thomas Nelson and had no math to take as a math
Really?
major. I had taken everything.
What did you take in high school?
I took up through Calc 2.
Oh.
So that's all Thomas Nelson offered. And there was one other math class that they offered, but it wouldn't have been useful for my degree. And it, like, well, it was math, obviously, but it was just, like, very different from what I would need. So it wasn't. So the only thing that I did in those 2 years was take physics. Which, yes, has math. However, very different math.
It's not like-
So it was
Well, at least
like
you could
sitting
focus
out for
on it.
2 years. So then I basically restarted in Calc 2 when I got to Liberty and I probably needed to go back to Calc 1 to be completely honest. But don't sit out of math. That's my plug for that. Like, I'm a math major and I sat out and it was awful. Definitely don't. So, all right, the next one say to state the sign, positive or negative, for sine of t, cosine of t, and tangent of t for the values in the given interval. So basically, this is what we've already done. So it's like, I'm just going to show you what they're looking for. So it means from pi over 2 to pi. So what quadrant is that?
1. Oh wait,
Pi over 2 to pi.
Yeah, 2.
Okay, so this is in quadrant 2.
I was looking at the signs. Sorry.
So it wants to know what sine, cosine, and tangent in that order is. So sine values in quadrant 2 are what?
Oops.
They're positive. Wait, is that what you
Positive, yep.
Okay.
Cosine,
I didn't know if that's what you-
Negative.
negative, and tangent,
Negative.
negative.
I wasn't sure if you wanted numbers or you wanted. I was like, it might really sound really dumb when I said positive.
Okay, so that's all you have to do for those, which basically I already wrote for you in your notes. So I would say try to do them without looking,
Okay.
but they're already in your notes if you need them. All right, next thing. Determine the sign, positive or negative, for the given value without the use of a calculator. So 18, tangent of 192 degrees. So basically, where, you can get out your unit circle if you need to, but where on that, or what quadrant is that degree value going to fall in?
That would be quadrant 3.
Quadrant 3, so tangent is what in quadrant 3?
Positive.
So this is in quadrant 3, and thus it's positive. You don't have to write what quadrant it's in. I'm just doing it for reference for you so that you like don't just see a plus sign written in your notes
Yeah,
and be
I would
like,
be
what
really
is that?
A month later, I'll be like reviewing it. I'll be like, oh.
You like positive?
Positive what? What am I
Yeah.
positive
For
in?
the test of these full size.
Tangent of 4 pi over 5. Where would that fall?
Ooh, wait. That seems like it would fall in quadrant 3.
Nope.
4.
Nope.
5.
2.
2. You would agree that 4
Oh,
pi over
yes.
5 is less than pi,
Yes.
correct?
Yes.
Okay, so it's got to be
Oh.
in quadrant 2.
Oh my gosh.
When I was thinking, see, I thought about that, but I thought about it wrong because I forgot it was a 5 on the bottom and not a 4. So.
So what is tangent there?
Tangent is
Negative.
Negative.
Yeah, my thinking process was right, but I thought it wrong.
It's okay, Josh.
We all
You're
thought
almost
wrong.
there.
We were all like, yeah, I think 3. Three looks
I
right.
just didn't say anything.
Okay,
Thank you,
good job,
Christian.
Christian.
Thank you.
I'm so glad.
You shouldn't have assumed I'm wrong.
Yeah, that'll never get me anywhere.
Yeah, you never need a right hand, right?
Never.
Never.
Never. That was funny because then he was like, everybody wrote.
I think it's most times.
Yeah.
Oh my gosh, I feel like my own chiropractor.
Oh, I love
Peyton
doing that.
is her own
It just, like, my parents are like, that's just what?
Chiropractor.
I've been aligned, and it's like the scariest experience.
I want to
ever.
go to a
Invisalign.
chiropractor.
You don't even.
I love
You
it.
don't even
I
have to
wanna
have like
go.
a. What is it? You don't even have to go to med school to be
You
a
don't?
chiropractor.
That's
No.
scary.
No, they go
You have
to,
to
it's
take, like,
not
a
med
course.
school, but it's like, there is like, there,
There's a course.
You
don't go to one that
You
doesn't have a degree
Get
in.
out of there and
Yeah, I'd be
what?
like,
You don't just like.
All you
break
need is a
people's
high school
bones.
diploma and then you just crack people.
You just, they
Yeah,
just, like,
for them, literally, you see them for like, well, mine I see the entire time, but the one I went to before, I would be in there for like a good 45 minutes probably, and I would say about 5 minutes of that, if I was lucky, was actually seeing the chiropractor.
What?
The rest of it was seeing their assistants doing like whatever random other stuff.
Yeah.
And I realized that's a really big ripoff. It was over $100 every time I went. Like obviously insurance wasn't that, but
Yeah,
if you had no insurance, over $100 every time you go.
Yeah, and
I was like,
you
that's
don't even, like,
insane.
do
Mine
anything.
is like 40 if you don't have insurance.
All
Where I
you
go
do
now.
What
is,
did you
like,
even do?
So when I used to go in and lay on a massage bed for like 10 minutes, and then I go see the chiropractor. He tell me that my spine is on the right side of my body, and then he aligns me. But that you don't get aligned every time.
On average, a
But-
chiropractor
I get
is
aligned every time,
$75.
but I don't go
Oh my
that
God.
often either.
Oh. And then they like
It seems so easy.
they do like a they
The
make you
neck
sit.
one is great.
They make you sit with like a thing on your head to like straighten your posture or something. I was like,
No, for real.
Oh, I don't
would
do that.
I would never
I
do
think
that.
they
I
need
would
to pay
accidentally
attention
like
to the
snap
anatomy
somebody's
class.
neck or something.
But it also depends on what you go for.
true.
So
Like, I used to go once a week.
I go for my jaw and my neck now.
Mm.
But like
Oh.
while I'm there, they also
I've
do
seen
my back.
chiropractor videos where they
I would not
they
be
take
that
the
person.
strap and like pull your neck
Oh,
like that.
no.
I'm like,
Mm-mm.
I would totally like.
I'm not-
kill
However, the
somebody.
first time I went, I was seeing the chiropractor and he was doing something, he was going to do my neck. And normally he'll be like, okay, basically they're like, okay, relax your head. And then basically they'll like do it.
yeah.
Well, he didn't tell me what he was going to do. He's basically just like holding my neck. And the next thing I know, it's like he's popped it. And I've never had this done before.
Oh.
And I was like, and then
Weird.
as soon as he did it, he was like, "Oh my gosh, I'm so sorry." And I was like, "Okay, that's
don't
like
say that.
not the words that I wanted to hear right now." And he was like, "I forgot to tell you what I was about to do."
Oh.
And I was like,
Okay. I thought he was about to say like you have
Sorry,
2
I
days
sorry, I
left.
just,
Yeah.
I just
and he
realized.
was like, "I've never in all my years of doing this have like forgotten to tell a patient what I was about to do like the very first time I did it." And he like felt so bad. I was like, "Dude, it's fine. Like I'm fine."
That's what you
Nice.
think.
That's what you think.
Then you just die 2 days later.
Oh my gosh.
They're like, be like, did you just kill me? Like, wait a minute.
I think the death would be in.
Be like, "Oh yeah, you're paralyzed for life now." Like, well,
Oopsie.
My
no,
bad.
I like the one that I go to now though. She's really nice.
You can be like, you get a 50% discount since like.
No,
Mess
you're
up your
paralyzed now. Since you can only use 50% of your body now. 50% discount.
Hopefully Nathan finds this entertaining when he watches this later.
Oh yeah.
Oh.
Congrats, you're paralyzed.
All right, these ones say to choose the point on the terminal side of theta. So basically, you're given theta. We want to figure out which point lines up with that.
Great.
Okay.
Ooh.
So, I test all of them usually. So, this one, so we have the tangent of theta is equal to, okay, just remember tangent is y over x. So is 1 over negative 1. Now the tangent of negative 1 is what? Or like where is tangent equal to negative 1?
Oh, in
Bad word choice.
quadrant 2.
Okay, in quadrant 2. And what is that like value equal to?
Oh.
3 pi over 4. Is that what you're asking? Or no? Or no? No, you're not asking.
Well, yeah, okay, yeah, that works.
I was like, I don't really know.
Okay.
I mean, it's also in quadrant 4.
It is in quadrant 4.
Yeah.
Yeah.
That's true.
But yes, okay. So it's 3 pi over 4. Just we're gonna go with that.
Okay.
Which is not that. Right? It's not theta, it's 2 pi over 3. Okay, so let's do the next one.
Oh.
There's another way that I would teach this if we had already done inverse trig functions, which is what you would have needed the other one for. I'm trying to do it without that. Normally I do it with inverse, but I'm going to wait because we haven't officially done inverse trig yet. So this one, tangent of theta would be equal to square root of 3 over negative 1 or negative square root of 3.
Oh, that is right there.
Thank you.
That one is 2 pi over.
It is 2 pi.
So this one is 2 pi over 3. So this one works. Just because there's not a lot of problems like this, I'm going to go ahead and show the last one. But that is the one that we want. But this is tangent of theta is equal to 1 over negative square root of 3. Or that's minus the square root of 3 over 3. So where's that?
Not at 2 pi over 3, so it doesn't.
Well, where is it?
It's at 5 pi over 6.
5 pi over 6, which obviously isn't it. So it would be B.
BB.
Yeah, normally I teach this with inverse tangent, and I was like, well, I can't really do that because we don't technically learn that till later.
I think that's
Why did they
4.7.
teach this before that?
Well, because you can just do it this way.
Oh.
I just normally teach it with inverse trig, and I normally do it on the calculator, but minor details.
I just feel like some sections need to like skip or something sometimes.
Yeah, well, sometimes it's like they need to almost like, it's almost like you need to teach all the trig concepts and then do problems.
Yeah, like all of
In
they
some
do, like,
respects.
tables for, like,
Yeah. All right, the last one just say to evaluate without using a calculator by using ratios in a reference triangle. You're just finding them off the unit circle.
Okay.
Why is it
Draw
Why
a
does it make it
reference
so-
triangle.
Because they want you to do it with like drawing the triangle and blah blah blah. Like I don't remember. Oh, they officially teach the unit circle in this section. So they want you
so
to-
We're already like.
Yeah, I teach
Wait.
it early because it makes other things easier, and it's
I
like
was gonna say, there's some
kinda
stuff in 4.2 that like
dumb to not
kinda
teach it
need to
earlier. Yeah,
look at the unit circle.
they want you to do it a different way, but
Oh.
it's like why?
This quiz
Yeah,
is
why?
Friday, right? Though the unit circle.
Yes, the practice quiz, but if you get a good enough grade, you don't have to take it again.
Okay.
All right, so let's just look at a couple just as a refresher, I guess, even though we just did this yesterday. Tangent of 300 degrees is what?
Oh.
Negative radical 3 or
Negative
whatever.
root 3.
Can never
Negative
say
root
that
3.
word.
Let's see, 28 cosecant of 3 pi over 4. So we treat this as what?
1 over cosine.
1 over sine.
1 over sine of 3 pi over 4. So sine of 3 pi over 4 is what?
It's still writing it. Give me a second.
Root
2 over 2.
So that ends up being, well, 2 over root 2, which is 2 root 2 over 2, which is just the square root of 2, which obviously you don't have to write all those steps. Again, I'm just showing mathematically how we get there. All right, one last one. 34 cosine of 17 pi over 4. So there's a couple ways that you can do this. You can either count yourself around the unit circle and every pi over 4 count 1 until you get to 17 pi over 4, which is going to be a couple times around. Or you can find the coterminal angle with 17 pi over 4. So just since we didn't do a ton of the coterminal angle ones, I'm going to do it that way. But you can absolutely count around. So 17 pi over 4, if I wanted to, I'm trying to get it down to an angle that I know, so I'm going to subtract increments of 2 pi. So if I needed it as something over 4, what would that be? Like what?
8 pi over 4.
8 pi over 4. So I'm subtracting 8 pi over 4. So that gives me 9 pi over 4, which is still more than 2 pi. So I need to subtract again. So minus 8 pi over 4 gives me pi over 4. So I'm now looking for the cosine of pi over 4, which would be what?
It's root 2 over 2.
Root 2 over 2. So honestly, the counting method is probably easier of just like, I would typically do that, but since we didn't do a lot with the coterminal angles, I wanted to, just show how to subtract that off again for some practice. That's all we're doing with this section. So your problems are 1, 7, 9, 13, 15, 19, 23, 25, 27, 29, and 31. And you'll have tomorrow in class to do these because we're kind of ahead.